Hey guys, what is up? Welcome back to this brand new video. Before moving forward into this video, I have to say this can become one of the very informational videos from my side on this channel, as well as like in the last video we studied about two pointers, right? And what did we use that for? Um, to find the pair of values from a given set of numbers which when added gives 0. That is, which are exactly opposite of each other. We can reach to that with a different approach. Similarly goes with this one. But this video, first of all, let me tell you something. Okay, let me tell you something. Let me tell you something. Basically, I read this question and I paused. Okay, to solve it, I took my copy out and let me just show. Where did I write it? Towards the very end. And with all this, can you just see? A little bit of crap, a little bit of crap. I I tried to write it, okay, and also this down thing took me really a lot of time to even reach to a solution, a nice solution, or even a working solution. Or gradually, I ended up realizing that the code which I wrote does not actually solve the question, solve some other problem itself. So I had a misunderstanding while reading the question. So let me just read the question out to you. Okay, so it's the count unique values. So basically, let me just give you the gist of what is actually we're actually trying to do here. We are given a like for example set of numbers here. This is quite a confusing number. Let's okay anyway. So you can see there are how many fours? There are four fours and one two. Basically, can you tell me how many unique values are here? There are two unique values, one and two. That is what we gotta find. Here also, if you can see, there is one, two, three, four, five, six, seven. So there are seven unique values in this one. And similarly goes with this one. This is an empty array, so straight away return 0. Length of the array is 0. Then straight away return 0. Okay, anyway, so down here is also something very cool. Can you tell me how many unique values are here? One, two, three, four. Four unique values. You understand what do I mean by unique value, right? Right now, yeah. So what I ended up doing is ended up finding the index, finding um, finding what ended up what I did by mistake, what I did, and what I went through in all of this copy kind of shit, and I'll show you further also what code I wrote, what refactoring I did, and later on realizing that all those things which I did was not even worth it. Anyway, so what I did, for example, here, the least frequency is of what? 1. So it used to give 1 as a unique count, like 1 is uniquely present here, like least number of times. So that is wrong. Like for example, here it would print out 2. This was such a confusing example which I ended up considering because of that only, the first one. Because of that only I was getting wrong answers. And for example here, so here what is the least number of time something is occurring? -2. Why not 1? 1 and 0, which it is also occurring one time. Yeah, my brain was like, brain and this is my code was like that the first occurrence of such a number will be -2. I'm like, what makes no sense, but okay. How did I do that also? I had a different way of doing it. Anyway, let's just read out what the question is saying. You understood the what is the correct thing? Correct thing is to find um, correct thing is to find like how many times not how many times, but it's like how many unique values are there. Like one is existing 4 times and two is existing 1 time. So we'll just consider it as two. One and two as two unique values here. Not two as a unique value. Two unique values. Oh, I got a pink lip. Pink lips. Pink lips. I don't know how, but yeah, looks good. I didn't apply anything. I ate good food yesterday. Okay. Count unique values. Implement a function called count unique values. Okay. Function count unique values which accepts a sorted array. Sorted array, bro. Sorted array is such a beautiful thing. If you have a sorted array, if you have applied some merge sort or some sort, I don't know literally shit about it. I don't even know the complexity of a merge sort, a worst case, a good best case scenario. I should remember those things. Like, okay, anyway, so if you create a function called const unique values and it accepts the sorted array and count unique values in the array. So it's basically counts them, as I told you, count the unique values, and there can be negative numbers in the array, but it will be sorted. So it's sorted means so it will be arranged in ascending or descending order. So you don't have to worry about negative numbers there. Basically that. You understood the concept, right? So implement a function called count unique values. This video is really gonna be lengthy, but please watch it through if you really wanna understand or if you're really struggling in this concept. Because I think I kind of actually solved this problem on my own, kind of. Use a lot of chat, not lot of ChatGPT, but actually ChatGPT too. If I was struggling with some condition, but I ended up coming with logic, which accepts a sorted array. Sorted array means ascending or descending order array. Unique values in the array. Unique values are in the array. They can be negative and a positive, as I told you. So we have gone through the example, right? Yep. Basically, we're gonna count different types of numbers there. Like one is a type, two is a type, four is a type, three is a type, seven is a type, 12 is a type, 13 is a type. So how many types? Seven types. Not going for the frequency of the type, like 40 occurring four times. We're not going for that. We're just going, you know what I'm doing. So this is so you can pause the video and you can apply your brain. So in the past video, what we did, we applied the pointers towards the very beginning and towards the very end of our object. Oh, of our array. But here, what approach I'm telling you to take is to apply the pointer at the very first, for example, here, and as well as straight away after that. Okay, I'll pause the video and I'll tell you to come back, as well as I'll come back with with a a paint or animation here so that you can understand drawing a sketch kind of. Okay, we are back now. Okay, so this is what I drew for you, that um, you can see here that we have, what do we have here? Okay, all the arrays are zero based index. That is, the first element is going to have an index of 0. The second going to have an index of 1 consecutively till like n, how far it goes. I've just considered an array of size 7 from 0 to 6 at 7. If you count also individually, you're going to reach to 7. 0 is included, that's why it reaches 6 here, but actually the count is 7. Yeah, so in the last video, which I was talking about, we have used two pointers, where the first pointer was on the 0 base index, and sorry, the second pointer was just straight up here on the last index. That was like, we had set the left one. Let me just draw it. Let me just write it for you. Let's make it more bigger so that it just stays on the head. So left index, and similarly goes with here with like right index. Okay, so the last video, the left index had a value of what? Can you say? Um, so it was equal to, what is the index? 0. And this is the formula we used. And this time, and the, okay, sorry, and the right side was equal to is equals to array dot length. Basically, the entire array's length. Array, let's short form array dot length, right? Let me just reduce the size of it. Let's just make it 36. Array length minus 1. Why minus 1? Because you know why. Because it will just search for 7 elements or something like that. We don't want that. Anyway, clear? So in this video, what I'm telling you to do is just put the pointer not there, but straight away here. And this time right should not be equal to 0, but right should be equal to 1. Should be equal to, let me just copy the 1 from here only. Should be equal to, copy, paste, should be equal to 1. This is what I'm saying. Forget about this one. Okay. So this is what we are saying. Using this logic, try to solve the question. Now pause the video and try to it. Let me pause. So yeah. So even before, yeah, before nothing, I was just saying. Okay. So what was I saying basically is without using this multiple pointer concept, I tried to solve it. Um, just using our previous knowledge of frequency counters. And you know what? As I told you, I ended up solving a problem which was not even asked. So, if you are interested, I'll be explaining this at the very end of the video. So, these are the codes for that. And even this code is not even proper. I chat GPT'd it and it told me I was just holding on to some variables which were unnecessary and were not actually used. So, basically, got rid of few of the values. But yeah, so this is the fixed one, and this is what is this? This was another approach of mine, which was also I think which is it's not that optimized because I think it's optimized only. I guess it's optimized O of n only the. Let me just use it. So um, website that tells you uh, the time complexity of our code. So time complexity.ai. Let's use this website. Just like taking lifetime, big O calculator. Clicked on every link possible, and all of them are taking lifetime to open. Time complexity and time analysis. God, none of them are working. Why is that so? Okay, one opened up. So I put the code. Oh, before putting the code, let me just try to explain you here. So what we did here, we just straight away created the function name, which takes in an array. But the thing is, it doesn't give a damn about if the array is sorted or not. But we don't want that. We want to use that concept. We want to take that concept on our advantage. And as you know that frequency counter is good, but two pointers are kind of better for solving some questions um, because of the less number of steps it takes, the how mindful it becomes in order to actually reach to the results, like so less number of for example, for example that if your code using frequency counter is taking, for example, let's say n steps to solve it. So how much time, you know what, this two pointers will take? N by 2. Not even kidding. Maybe less than that, and by 4, who knows. So that quick it becomes. But as you know that when we are solving in terms of n or n by 2 or 2n or 3n or 100n, it doesn't matter, it should be n. So time complexity is like doesn't matter. Time complexity overall, the fuzzy calculation, if you see, is, yeah. So let me just try analyzing. So did it run? The code iterates through the input array. Okay, did it? I think it run. Analyze. Oh, after clicking on analyze, it just says the function iterates through. Uh, the function iterates through each element in the. अबे यार क्या हो रहा है? किसने बनाया है website? And stores the count of each unique element in the object. The final step involves getting the number of the keys in the object, which is a constant time operation. Whoa! So I was thinking to this one would be of O of n or n square, but it was just straight up O of 1. So therefore the overall time complexity is O of n, where n is the number of elements. So crazy, bro. So let me just again get deeper into this concept. What's happening here? Basically, we create a function, and we create a function, and we create an object, and our object is empty, like the traditional way of writing frequency counters for at least like one array. And what we do here, we use a for off loop. It's a very quicker and quite elegant looking way of using for loops. And what we do basically, we iterate, we create a variable called elements, and that element will hold all the values all the each and every elements of the array, and will hold it in the elements named object. So what we are doing here, we are just basically setting that if that element exists, okay, if the certain element exists, okay, or that certain element doesn't exist, okay, in that very case what you have to do basically is that if that element doesn't exist, we just add that element into that object and set it to 1. If that element already exists, basically do nothing but increment it with 1. If it was 1, make it 2. If it was 2 already, make it 3. But as you know, in the first iteration, it will not be there anything. But in the second iteration, chances are that, okay, second time the loop is running. So, okay, if that value exists, let's iterate, increment it 1. But the first iteration will happen nothing, but we have to add that very element into our object, our empty object. And at the end, what we do, just straight away return object dot keys, and what we do here, we put in our object name and straight away put the length. So you would be saying, why can't we just use this, object dot object our object dot keys? But no, we have to specify what are you actually what are you actually trying to find. You're trying to find the length, so it has a time complexity of 1, which is a god level time complexity according to me. It's like, it's not even, it's like constant time, so crazy. So let's just try and run it. So here actually there are 16 or 17 unique values. Let me just check. I mean, you also count with me. One is a unique value. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So we have 17 unique values. So what should be the output? Of course, 17. Let me just run Control Shift Y. So I don't give a damn about this. Is like previously logged out results. So we just press F5. 17! Crazy! So we get the output as 17. So it is working code. So this is what was actually like finding the unique value. So this is how you can do it. And this is not bad complexity. This is O of n complexity, and I'm proud of it. But the thing is, you should remember at least like what is the code here and how to put in an element in an object. So if you don't remember that, mug it up, because I just tend to forget it every now and then. I have to refer the notes. So, and as well as you have to remember like object.keys and your object name and dot length. So this will basically return it. Crazy. Now, multiple pointers. Before multiple pointers, keep this diagram in your head. Okay? Keep this in your head. Okay, crazy. So just I'm taking some pause so that I can come up with more energy. I'll drink water and come back. Crazy. So now using multiple pointers at the starting and the end of an object, end of the array. No, starting, using multiple pointers at the starting and starting plus 1 basically, and starting plus 1, like straight away after that. Like if it is, if we are putting the pointer, where's the paint? If we are putting the pointer here, the next pointer, the right side pointer should be present here. That's basically that. Don't worry about it. So we have trying to solve it using that also. This was very good experience. Like it took me hours actually, watching movie, cooking food, trying to do code, talking to friends, watching Instagram, everything. So it took me that much time. So what is it all about? I'm very excited to explain you this. So we have to basically create a function as usual. Count unique values. Did we comment everything? Yeah. Count unique values. So this is our code basically. Yeah. Okay, and we put in an array, and this time the array should be sorted. Do we care about being sorted? Yeah, we do care about it being sorted, because if you look into this diagram here, you can see different shades of green and different shades of red. And here somewhere in between we have 3. I shouldn't have put the 3 here. I really did not know what color to put here. It's basically imagine 3 as a place where red and green combines. So on the right hand side, it's the bigger value, and on the left hand side are the values which are closer to negative or closer to 0, or 0 itself, those values are present there. You understand it? On the left hand side we have smaller values, on the right hand side we have bigger values. What values am I talking about? I'm talking about the numbers which are put in here, as well as the index also. You can compare, like, on the left hand side there are smaller index, on the right hand side there are bigger index, like that. Like, for example, we have values like the funny thing right now is that we can have same values as well put into the number, as well as negative numbers. So let me just put some negative numbers, bro. Let's just put in -1. Let's just change the color of this. -1. Oh. Okay, we put in -1. How do I change the color of this? Okay, like this. How do I change the color? How do I change the color? Crazy, bro. I forgot to change the color also now. Anyway, just keep it the way it is. -1. We have another number as -1. And should we put -1 again? No, let's just put no, instead of putting -1 here, let's put -2. Let's put -1 twice, -1. I can use -2 as well, but let's put -1. And let's put -1 again. Let's just satisfy the colors here. -1. Let's put the 0 here. Okay, good idea, right? Yeah, 0. And let's put in 2. Let's put in 3. Let's put in 3 again. You know why we are doing it? So can you tell me how many unique values are there? 2 is unique, 1 is unique, 0 is unique, 2 is unique, 3 is unique. -2 basically. 1, 2, 3, 4, 5. So the output should be 5, right? Crazy, right? So far so crazy, right? What is this? Yeah. How do I get rid of this? So what more do you need here, bro? Crazy, it's already done. Do you understand what's happening? I don't understand. Let me just pause it for a while. So let's get back to the code first. So what our code does is, like, it sets left to 0 index. Left to 0 index. Like, yeah, left side is set to 0. Like 0, this place, left side. And the right side is set to 1. If you check carefully, it is set to 1. Set to 1. And this code is not efficient because this code contains some unnecessary variable uses, like count. We don't even need it. So just get rid of it. And even the condition here needs to get checked, needs to get refactored because it's a wrong condition here. As well as here, it lacks some more thing. Let me just explain what is happening here. Okay, please just try to bear with me. So this time it is set to where? It is set to 0 index, okay? The left index. And the right index is set to what? To 1, okay? Okay. Okay. So what it will do, it will compare left and right indexed values at -2 and -1. Are they equal? They are not equal, right? Are they equal? So they are not equal. So they are not equal. So if they are not equal, I got confused. Wait. Okay, I wasn't doing wrong. I was doing right only. Basically, the left pointer is set at a 0 index and the right pointer is set at 1 index as per as our code. You can see that. Where's the code? Yeah, right. They needs to get tweaked and everything, but let me just tell you the all over idea. So left is pointer, right one. Basically, if we compare the left pointer value, talking about the values they put inside the box, if it matches with the right pointer values, if it matches, in that case you have to move this right pointer towards one step further. But in our case, let me just get rid of this weird ass thing down there, like The initializers. We know how initialize to what. R is to 1 and initially, the very first before even iteration. Okay, clear. I'm sorry for taking so much time, bro. But I'm like kind of weak in these concepts, so I just wanted somebody to understand because I understood it. So basically here, so are they same? Can you say are they same? They are not same. The first step would be doing what? Will be moving the left pointer index from 0 to a bit more right side. Let me just reduce the size of it so that towards the, oh god, it became so small. Towards the right side, we have basically incremented. We have added initial value of left pointer was, let's say, 0. Now we have added 1 to it. Look, basically left plus plus code we have used. What we have used? Left plus plus. Left plus plus. When they are not equal, here it is when they are equal. So increase the right incrementer, but right arrow, that the light pointer. But if they are not equal, in our case it was like 2 and minus 1. So increase the left increment. Okay, but this is just not done, bro. We, as you have moved forward the left, whenever you move the left pointer, you have to update its value. You have to do what? Update its value. Really? For real? Um, yeah, you have to update its value to. Do we have to update its value? Let me just think. Oh God, I again got confused. Wait. Yeah, you have to update its value. Updates its value to what? To whatever the right pointer is at. So in our case, it got updated to minus 1 only. It was initially minus 1 and it became minus 1 again. So we don't have to worry about that in our case right now. Okay, now what it will do, it will again compare that minus 1 is associated with right and as well as minus 1 is associated with left. So they will compare. Are they equal? Yes, they are equal. So in that case, the right pointer moves a bit further. Okay, right pointer is incremented with 1. Now in this case, they will again compare. Are they equal? Okay, the left pointer has minus 1 and the right pointer has again minus 1. In that case, it has to move a bit more further without making any changes. So whenever we are moving the right pointer, we don't make any changes. But whenever we move the left pointer, we actually updates update the value. So okay, in this case, can you tell me what's happening? Okay, so I is of index 1, L is of index 1 and R is at index 3, and basically what is happening right now, they have different values. We have minus 1 and 0. So in this case, when they are not equal, what we do, we do the same process of incrementing its index from whatever it was to furthermore towards the right side. Crazy, right? So this is just not done. It's not like right pointer that it will not do anything after moving. When it moves one step, it will just straight up copy whatever is the current value of the right pointer. So it was 0, so it ended up changing its value from whatever it was like minus 1 to 0 now. So now what it will do, it will again compare itself. Are they equal? Sadly, they are equal. So we have to move a bit further. So it just reaches to 2. Now, since we have moved just the right pointer, we don't make any changes. But right now we have to move again the left towards a bit one more step, because as you know that 0 and 2 are not same, but after moving only we have to straight up update its value from 0 to 2. Okay, makes sense, makes sense. Now, are they equal? Yes, they are equal. So what we will do here, we will further move this right to one more without making any changes, because whenever the right moves, the good person, it makes no changes. Now, what are they equal? Yes, they are not equal. So we move a bit further and we update 2 to 3. Crazy, crazy, crazy. Okay. Now can you tell, are they equal? Yes, they are equal. We have to again move the right without making any changes. Now are they equal? Yes, they are equal, and we cannot move it any further, so we have to stop here. So so the loop should run maximally of Um, I don't know what should be the condition, but we'll figure it out. So this is the whole concept. Now you can see the left pointer. What is the index of left? 4, right? Now can you tell me how many unique values are there? 4. Wow. So without using much brain, we ended up getting the unique values without putting it into an object, without creating the frequency counter for it. It can just use 2 pointers and you can do it. So this was one of the way. And the other way is putting the left and the right like that. And we'll show that as well in the coming time. So what I'm saying basically is like we have to put it at this end and we have to put right here, left and right at the very codes with the very edges, and then we'll solve it. But you got the basic idea of what this code is doing right now, right? So again, let's read the code so that it makes a lot of sense right now. So we have used the function keyword and we use the count unique values and we put in an sorted array, and we have left is equals to 0 and right equals to 1. Told you right. Told you right. The left index was 0 and right index was initially 1, right? Yep. So does what further does what? So it goes into a while check. So it iterates through count. So as I got rid of count, so you have to get rid of count as well. So let's use right here as our reference of our condition. Like while condition will run until unless certain thing is true. So um, so I don't know what condition should I use. I'm very bad with using conditions. Um, Anyway, just let's like iterate um, array dot length till the time right is smaller than array dot length. I think it will work. Okay, so we have used right. So array will right side is how many times? But instead of using right, let's use left. Because left has a 0 index, so it will include 0, and yeah, it will run the right amount of time, I feel. So yeah. So till this is running till that time. So inside the if statement, what we have put that if the array left array element and right array element, if the left pointer element and right pointer elements are equal, in that case you just increase the right pointer towards a step further. That's what we did for so long, right? We kept on increasing when they were like, for example, in this case, when they were same, what we did, we just in this case when they were same, we just increase it further. In this case also it was same, so we increase it a bit more further. So right pointer is moving if they are same. Else, if it is not same, you have to increase the left pointer. But at the same time, when they are not same, you have to set left. You have to, what is the value at left when the left moves, you know what it does. For example, in this case the left is moving a bit further, but at the same time what it is happening, the index, the value of left is assigned to the value of right is basically assigned to left, right? Like 0 is assigned to the left. But after moving further, that it has to move a bit further than make the changes. You know what I'm talking about, right? Like it has to move a bit further, and then we have to update its value, right? It has to move further, and then we updated its value. Basically, copy pasted its value. Now it will again compare. They are same. Move a bit further, blah, 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 whatever. Get the point. So the value at the left, it should be assigned to whatever is the current value at right. Bro, I love these concepts, but these were like pain in the ass. I'm not gonna lie. Let's get rid of this. And at the end, we should return the value of left. Oh, by the way, I didn't tell you one thing. For example, let's just get to the situation where it was before. Oh, I can't do that. Uh, Let me just copy paste it here. Just paste 2 here. Just paste 3 here, and just this thing reached the very end. And so here, can you tell how many unique values are there? There are 5 unique values exactly. Since the left pointer points towards 4, right? Towards the left pointer points toward 4, and we were considering, yo, maybe this is the actual number of unique values, but no, because it's based on zero based index, you have to increase it with 1. So that's what we do here in our code. We increase the left pointer, whatever the value was, with 1. Okay, this left is basically what? An index. Index is incremented with 1. So do you think it will work? So as we discussed, there were like 17 unique values. So will it work? Will it work, kiddos? So let's just try and use it. Conditionify. Okay, so it went into an infinite loop, so it's not running. So we not have to use left till the time till the time. What logic should I use here? Till the time. What logic should I use here? I don't know, man. What logic should I use? Then instead of using right, let's use right. Let's see if it is happening. I'm very bad with conditions, I told you. So it's working. So it should, we have to use right. So till the time right is smaller than that. Anyway, so you have to use the keyword right here. So yeah, it's happening. We are getting the result. But sorry for making this such a hodgepodge. Um, Same concept applies here as well. But here we have used a bit of short circuit that we have. This is the same only, but the only difference here is um, here a little bit of if condition is changed, like we have just vice versa the rule. It's same only. You can use that or you can use this. But you have used a short circuit here. Like is the length of the array is straight away 0. So what are you gonna compare it with? Compare it with nothing, right? So straight away return 0. So for that case, you have to use right and smaller than length of the. Anyway, so it's working. It's fine. So I'm sorry this video gets so long. I don't know how long this video got. Let me just check. I have no idea how long this video has become. Maybe I should check here. There's no counter. That's crazy. Oh, anyway, okay. So you are using again the multiple pointer concept. Sorry for again lengthening this video so long, but I'm excited to explain this. At the starting and the end of the array. For example, when we have these pointers here and here. So as I told you, it should have an index. What should have an index of left should have an index of 0 and right should have an index of 6. Not hard coded. Always try to make your code dry. So on that using that, do not repeat yourself. So for that very not hard code stuff for on that very concept. So we're gonna set right to array.length -1. We discussed that in the very beginning, right? So yeah, it will put that at the very end of that array, and this will put that at the very beginning of the array, setting it left to 0. Okay, cool. Just get out there of this, man. So crazy man, crazy. Okay, so what we do here is write a state of a function, set it to left. This is not the right one. Yeah, that's not the right one. So this is the correct one, basically. Yeah. So, yeah. So again, we create a function, count unique values, and left is set to 0, and we are right at the very end of that array using array.length -1, right? So we are short circuiting straight away in the very beginning. If the length of the array is 0, it's never return 0. Lazy, right? So we is using while thing, and okay. Now the condition is kind of fucked up and unique, so I'll try to let you ignore it. I gotta have a strong understanding of while, a very bad understanding, and the condition we put it inside. And in terms of arrays, I have a very bad understanding. We'll figure that out later. So what is happening here is just like, do you remember like that the last past video where like we used multiple counters like sum 0. So the same sum zero concept we have used here, and that's it. So we start from like, if the left array is equal to right array, then what we do here, this is crazy. Okay, let me just show what's happening. We are saying the left, if this and this are same, if you both guys are same, if you both guys are same, in that case you have to decrement it further. You have to decrement the value of right bit further, and after you have decremented, oh, it is not same in our case. For example, let's say it was here and it was here in this case. So bad case, very bad example. So in this case, both of them have same value, so it will move further. Again, they have same value, so they will move further like that. You have to decrement right, not increment right, decrement, because you have to come towards the zero. 6 here. We are talking about the index. We have to decrement the index towards it reaches its zero. When it reaches to zero. So yeah, we have decremented the right value when they are same. When they are not same, you have to increment the value of left, like the past time only. So increment the value of left, and they are not same in our case. And we have to assign, let's say 3 in our case. You have to assign 3 here, like that. I know it made no sense with that diagram because there were different values, but try to understand the basic point of it. Okay, so like that only, like past only, we have to increment the whatever index it reaches. The left reaches to 1 because it's zero based index, so we want the right number of values. So crazy. Let's see if it works. Control Shift Y. 17. We get the output 17. So after trial and error, I got to this conclusion that let's write left is greater than right times right. But let's try one more thing here. Let's try right is smaller than array 1 dot length. Right. Let's just see what happens. Control Shift Y. Okay, it goes into infinite loop. So let's just do one thing here. Let's cover it up and let's add when it is not equal to, because let's see if it works. Sorry for that typo. So yeah, it's not working. So my idea was, let's use left then. If it is not. My idea was like, use this left is smaller than right square. So it does solve the problem. For example, if there is 31, so how much? What should we? It should be 18, right? We get the output 18. If there is 33, should give. So yeah, it went out of bounds. I really don't know what code should I use here. Again, you have to use right times right. So this time it will work, I guess. God, no, it's not working. You have to use the right amount of iteration, bro. So for now, this is damaged. I don't know how to fix it. I'll fix it later when I'll become intelligent. So let me just give a quick reminder for myself. Fix the while loop condition, please. Condition, please. So whatever. So now output. Cool. That's it for the video. But if you are interested, you can leave the video right now. I know you have already left, but those who have stayed and they're more curious, like what kind of crap did I do? I can understand this, so I'll show you what I did. So we created a function called, and we created an object that basically creates keys and values, and value will be the frequency of those very keys. And I created current key as null, previous key as null, current value as null, and previous value as null, and our required value as null, and our required key as null. Bro, you see how pain in the ass kind of like it is. Some variables are here unnecessary, and what we did, we uses let for in kind of loop to iterate through all the keys present in an object. So we set the current value, we set the variable value to our object's current keys value, okay, and current key as key and current value as value, and it worked. It did work. Okay, but let me show you the refactored version. This is kind of pain in the ass to see also. So So this is the refactored version, and this is short also. All the refactored versions of ChatGPT are so short, but it fails to answer few of the basic questions at times. So this is what I did: create a function that unique value is taking stored in an array. Let's say 1. We were trying to find frequency counter for least number of frequency occurring element, basically like that. So similarly, we create an object, we iterate, we put in all the values of the array in the object, unique values, you know what I'm talking about. And we create two variables, our required values, our required key, and our required key and our required values. So what we do, we just create a for in loop, and here you can see it's quite interesting. Is it getting recorded in the first place? Yeah, it is getting recorded. Hi. Okay, audio is working. Crazy, crazy. So gonna get 1 hour long video. Fuck. So yeah. So basically, it is saying if your current value, if your required value is not already existing, or if you have a required value, in that case, compare the current value to the required value, and if the required value is greater than the current value, then set our required value to the value and our required key to the current key, and set up, log that out. So let me just show you after running what happens. So we get 1. Why is this 1 coming as an output? So yeah, least number of time 1 is occurring, so that's why when we get 1 output. For example, let's say 0 was there, so it will give 0. So that was all about my code, and this was such a fucked up code, and why do I write such a shitty thing? So this is how we end my documentation process of multiple pointers. And I'll catch you in the next video. Till then, take care, be safe, and keep DSAing.